Hi there, Tech Math class. This is Mrs. Warman, and I'm going to cover some of the sections in 2.3 and 2.4 because I don't feel like I was able to cover those very well in class today in the short time that we had. So hopefully you can see this whiteboard that I have up, and I'm going to start with the significant figures. We did cover the significant figures pretty well, but we didn't get to the point where we were talking about rounding those significant figures. So if I had a number 70,360, and I'm told that I need to round that to 3 significant digits. These three numbers, 7, 0, and 3, are my first 3 significant digits. So that tells me that this is the number that needs to be rounded. So my number will become 70,400. So I took the number 70,360 and I rounded it to 3 significant digits. 7, 0, and 4 are my 3 significant digits. Excuse me. Now let's say I have the number 39.72. This is a decimal. It's not showing up very good on the screen, but it's 39.72. And let's say that it tells me I need to round off to 2 significant digits. From the left, I go to the first 2 significant digits, which are 39, and I need to round that. 39 rounds. I do have this 7 here, so I have to consider that number when I'm rounding. So my 9 becomes a 0, and I carry my 1, which makes this 40. So 40.00, or just 40, because of 2 significant digits. So I took the number 39.72, and I rounded it to 2 significant digits. And it became 40. Okay, now if I have some approximate numbers like 73.2, 8.0627, 93.57, and 66.296. So these are approximate numbers, and if I add those, I end up with 4 decimal places at the end because my longest number has 4 decimal places. So in addition or subtraction, the number of decimal places in your answer should be the same as the least number of decimal places in any number being added or subtracted. So even though I would add all of these out to 4 decimal places, I would actually round this to the least number of decimal places in any of the numbers being added or subtracted. So my answer, I actually end up with, I don't have room here on my whiteboard, but when I put these numbers into my calculator, I end up with this. But that's not the correct answer because we have to round to 1 decimal place in this example because that's the least number of decimal places. So my answer becomes 241.1. So this right here would be the correct answer for this problem. So now if we take 292.6 divided by 3.4, we could also write this 292.6 divided by 3.4. We get an answer of 86.0. Hang on, let me write that somewhere else. I'm going to write it up here. 86.0588. Now, in this problem, 3.4 has the least number of significant digits. There are 2 significant digits in the number 3.4, whereas this number, 292.6, has 4 significant digits. Therefore, our final answer should be written to 2 significant digits, because in multiplication or division, the number of significant digits in the answer should be the same as the least number of significant digits in any of the numbers being multiplied or divided. And this least number of significant digits, it's 2. So we should only have 2 significant digits in our answer. So when we round 86.0588, our answer is rounded to 2 significant digits, and 86 becomes the correct answer. Those rules can be found on page 65. There's a blue box at the top of the page that says expressing results dealing with approximate numbers. And there are 3 rules when you're talking about it. It also has a rule for when you're working with the root of an approximation, but there will not be any of those on the test, and we may get to that point where we cover that in a later date. So always remember, when we're rounding, you're always going to consider the next digit to the right. So if we're talking about 32.645, and we need to round this to the 4th significant digit, we have 1, 2, 3, 4 significant digits, and we have this number 5 right here. If the digit is less than 5, we accept this digit in its last place, so we're not going to change that. It would round to 32.64. So if this number right here is less than 5, so if it was 4, 3, 2, 1, or 0, we wouldn't change the 4. Now, the book says if this digit is greater than or equal to 5, so our book says if there is a 5 here, or if it's greater than 5, this 4 rounds up. So our answer that is correct becomes 32.65 if we're rounding to the 4th significant digit. Okay, so that's dealing with significant digits. And don't forget about the approximate numbers, exact numbers, and the precision and accuracy of numbers. Now we're going to go back to that conversion and reduction, where we're talking about unit analysis, and we're using unit analysis. Excuse me. So let's say that we have a laptop that weighs 8 pounds. And we are needing to convert that to kilograms. We would look in our book, or for the test, your note card on page 56, and we would look at some conversion factors and find out what how our relationship exists between pounds and kilograms. And we know that for every 1 kilogram, we have 2.205 pounds. So to write this problem, we have 8 pounds Okay. It doesn't like me drawing a dot, so I'm going to use my times. And I need pounds to be on the bottom so that they can cancel out. And we know that 2.205 pounds is equal to 1 kilogram. So now we can figure this problem. We can cancel out our pounds because one is on the top and one is on the bottom. And we're left with kilograms, which is what we need to find. So we're left with 8, read my own handwriting. 8 times 1 is 8. 1 times 2.205 is 2.205. So 8 divided by 2.205 gives us 3.63 kilograms. So we took the 8 divided by, that's what this line here means, is divided by 2.205, and we put that into our calculator, and here is our answer. And this is called conversion because we went from the U.S. customary system to the metric system. Okay, so now let's say that we have some copper wire, and that wire has a diameter of 0.0253 inches. And we're needing to find that diameter in millimeters. So we're going from inches to millimeters. And if we look again at that table on 56, we have to find some things that have a relationship. And we do not know exactly how many inches are in a millimeter, but we do know how many centimeters are in an inch. So it tells us that there's 2.54 centimeters in an inch. So we could write that down or look at it on our note card. So we start our problem with 0.0253 inches over 1. I think I'm going to run out of room. Times, our inches needs to be on the bottom here. And there's 2.54 centimeters in every inch. So 2.54 centimeters. Now we have to convert this to millimeters. So we have to know how many millimeters are there in a centimeter. Well, remember that line I drew on the board? Pretend that's centimeter. Okay, so we're going to put centimeters on the bottom and millimeters on the top. So how many millimeters are in 1 centimeter? Well, we're going to put 1 right here above centimeter, and we go over to millimeter. We add 1 decimal place, so our decimal was here. We add 1 decimal, we get 10. So there are 10 millimeters in every centimeter. Now we can start our process of canceling. Our inches cancel out. Our centimeters cancel out. And we're left with 0.0253 times 2.54 times 10. Those are all the numbers on our denominator, millimeters, which is what we need to find. And we do have on the bottom in the denominator 1 times 1 times 1, but we know that whatever answer over 1 gives us that answer. So if we were to put that into our calculator, we end up with 0.643 millimeters. That's our unit. And you don't need this line or the 1 underneath it. Here is your answer. And there is a point here. For some reason, it won't let me make it that larger. Okay, and then the last one we're going to do here. Let's say that we have 326 milliliters, and we're trying to figure out how many quarts that is. So if we go to page 56, we'll look and see if we can find kind of a relationship here between milliliters and quarts. And the only one that I can find that's close is that 1 quart or 1 liter is equal to 1.057 quarts. So this will take us 3 steps at least. So we're going to start with our 326 milliliters over 1. And we need to figure out how many milliliters are in a liter. So our milliliters is on the bottom so they can cancel. And our liters goes on the top. Liters are bigger, so I have 1 liter, maybe if I can get it drawn, over how many milliliters. Once again, we use our little line here. So we have liters. The third tick is milliliters. So if I have 1 liter, I have 1,000 milliliters. Now I need to find out how many liters are in a quart. And we already found that information out. So our liter goes on the bottom, and on the top we have 1.057 quarts. Now we'll start canceling. Milliliters cancels, liters cancel. We end up with 326 times 1 times 1.057. If I had enough room here, I would write all this out. Over 1,000, we're left with these units, quarts, because that's what we need to find. So if we're left with those, that's perfect. So we take 326 times 1 times 1.057 divided by 1,000. And what do we end up with? We should end up with 0.345 quarts. Hopefully that helps clear some of that up so you can be prepared for your test. There will not be any questions that deal with the root of an approximate number. There will also not be any questions in the unit analysis that deal with, like centimeters cubed or meters squared. I have taken all of those out. So hopefully your note card is nice and full front and back, and be sure to bring a calculator. Have a great Labor Day weekend, and I will see you all Tuesday morning.